All right, so this is ICT Revision Notes Chapter 7. We're looking at System Lifecycle today. I encourage you to hit the subscription button, like the video, and tell others about it. Okay, let's kickstart. In this chapter, we aim to revise, analysis, design, development, and testing, implementation, documentation, and evaluation. Let's take a scenario. Now, system lifecycle basically has to do with the idea of developing a new system, right? Or improving upon an already existing system. So let's take the scenario of spokes and gears. These people are into bikes, and they realize that the way they do inventory is giving them a lot of issues. They have some delays allocating bikes and difficulty in managing stock levels. So because of that, they want a bigger or a better system or platform that allows them to rectify these errors that they have identified. So in doing that, they want to come up with an e-commerce platform to sell bikes and other accessories online. Now, if they are successful in doing this, they have to first of all install this software, and then again they need to evaluate and see if it is working exactly the way they want it, and if it is not, they need to make the necessary adjustment. And that is basically it about system lifecycle if we think about the whole scenario. Now, so you notice that there's an evaluation stage where after the system has been developed, it needs to be looked at to see if it is exactly what the company wants. If it is not what they want, then again, there need to be some adjustment. So the process just becomes cyclical. In other words, it continues again from the top all the way down, and then it goes on and on and on. So system life cycle in general can be identified or remembered. The stages can be remembered with this acronym, ADDIDE, or some say ADDIDE. So whichever way you want to pronounce it, that's okay. But it's ADDIDE. All right. So if you remember this acronym that came from, just the first letters of the stages, you should be able to remember all the stages of the system life cycle. And so diagrammatically, this can also be viewed as we see on the right. Okay, so we now want to look at the first stage, the analysis. Now, the analysis has a number of stages, right? So it involves finding out, the analysis actually involves finding out how the current system works and what the requirements of the client are for a new system. So the analysis stage has about 7 things to look at. So first of all, if you have an existing system, right, and you want to look at improving on it, then there's a need to do some research into the system, all right? So in doing research, the next thing to do is to identify what kind of input and output devices you're going to use as far as this system is concerned, what processes will take place in this system, problems the current system is meant to solve, and then some of the requirements, the user requirements for the new system must also be looked at. The questionnaire in most cases could be online or paper-based, right? And then you also have interviews where you engage stakeholders to guide them to make decisions about the system. And then finally, if it's an already existing system, then there's some document that the expert, the system analyst can look at to decide what to do or how to improve upon the system. So these are the main distinct methods to research into a system. Okay, now some advantages and disadvantages of the methods that we have mentioned, the research methods. The first one is observation. So we know that when you are watching people, obviously they don't feel comfortable, so they will fake, how things are done. So that will be a disadvantage. So workers may not perform tasks, against standard procedures, because when people are watched, they want to impress. Okay, so that would be one disadvantage. Now, another advantage is that you obtain first-hand information. So information that you see are reliable, and better overall view of the system. And then it is not expensive at all. You don't have to spend much in this. Just sit at a distance and then watch what is happening. Then you can clearly see how things are done. The input and the output can be seen. Interviews, on the other hand, is a one-on-one question and answer sessions where you sit with the client and then you find out from them. If you are the analyst, you find out from them what is wrong, what they need, or even with the users of the system, how they see the system, whether they want some improvement on the system, and such like that. So that has to do with the interview session. Now, some advantages of the interview session is that you give opportunity for people to open up and give honest answers to developing the system. Then it allows for probing and follow-up questions. So it gives opportunity for people to clarify things if they don't understand something, and then can modify questions as needed. So as the interviewer is asking questions, it's not just cast in stone. Questions can be modified as they are being asked. The disadvantage to this is that it's time consuming. It takes a lot of time. Even scheduling meeting with people sometimes is difficult. Then again, we look at price wise. So it's relatively expensive in a sense that sometimes if you need to organize people to interview them, you need to give them a token. All right. So, and then in most cases, the interviewee want to remain anonymous. They don't want people to find out what they have said, and this may lead to potential dishonesty. So people may not be really honest sometimes when you ask them questions that are quite sensitive. Okay, and in some cases the interview also can be biased, and then give or tell you exactly what you want to hear, not exactly what the issue is. So those are some disadvantages to interviews. Questionnaires and examining documents, on the other hand. So some disadvantages to questionnaires is that it's low response rate. If you send a questionnaire to people via email, not everyone reads their email. A lot of people find it easy to read information on social media than even reading their email. So low response rate. Not everyone is going to respond. And then questions often are generic. They are rigid, straightforward. You can't ask for clarification if you don't understand something. So no immediate clarification for vague answers. Is that okay? And then users tend to exaggerate responses instead of giving you honest responses. Some advantages to this is that you get immediate feedback. The response are quick. It's not that expensive. If you're using Google Form, for example, to gather data from people, it's not expensive. Quick data analysis, you see graphical display of the answers based on responses that you get. And then the last one is examining the existing document. So in examining the existing document, you have to obtain the documents, that is the user document and the technical document, and then look at it intensively. So you need to make time, read and understand what is actually written in those two documents. And so a disadvantage is that it's time consuming and relatively expensive. It requires an expert to look at the technical part of the document, and in order to really give you more details about it. On the other hand, the advantage is that you directly can obtain unique information you can easily obtain unique information just by looking at the document. When you talk about document, the user document, there's no need to think too far. The receipts that we receive from buying items is an example of a document. So if you look at a print out of a receipt, for example, you should be able to tell where there's a need to do some adjustment if the receipt you see doesn't have much information or it's not detailed enough. It can be improved upon. So direct observation of the system operation is what you see if you look at a receipt. So that explains the last part as an advantage. So you can directly see how the system operates when you look at the document. The next stage after analysis is design. So based on the analysis that has been made, you need to do some design, okay? So some design include file structures and data structures, the input formats that include how data needs to be captured, output formats that include how the screen layout and then the report layout needs to look. So, and then we also have validation routines. So these are the main things to look out for as far as the design stage is concerned. So let's take the first one, which is a file structure and data structure, and digest that further. Okay, so when we look at the file structure or the data structure, basically we just want to look at the data types, okay, and the descriptions you give to each data. So if you are designing a database, for example, each field needs to have a specific data type. So in the same sense, I mean, every system has some data structures that helps it to work accurately. So we have the alphanumeric. So an example is just a combination of letters and numbers. Characters just have symbols. I mean, basically letters or symbols. And then text, we have just strings of characters and symbols that are put together. And then we have Boolean, that's true or false, yes or no kind of question. And then you have numeric kind of data, that is integers, decimal, currency, and then dates and times. Then we look at validation routines. When you enter data into a computer system, there's a need for it to be validated. In other words, you want to see whether the information that has been put in, follows some specific criteria or rule. Okay, so we have the Boolean check, and then we have the data type check, and then we have present check, length check, consistency, range, format check, and then check digits. So when we look at the first one, which is the Boolean check, it's just trying to do two things. So it's checking whether the content is either yes or no, and that's it. It does nothing else. It shouldn't accept any other data apart from yes and no. The next one, which is the data type check, ensures that the correct format of data is entered into a system. So for example, if a field is supposed to accept only numbers and you find characters in there, then there's an issue, or the system is not going to generate good products for you. So you need to do some validation so that you have a field that needs to accept only numbers, accepting numbers. Presence check, a good example has to do with filling forms online. So you'll notice that some fields have some asterisk signs put to them. So they are mandatory fields, and that it just ensures that you do not leave those fields blank when you are filling in forms. So they ensure that every field is filled. Length check, on the other hand, ensure that the character you put in is of a certain length. So for example, if you are typing in your password, for example, for an email, there's a certain length that it needs to reach in order for it to work. Okay. And then on the other hand, we have the consistency check that ensures that if you have a name, a gender like male, you do not have miss going for a title. No, so it checks to make sure there's consistency. So if you select Mr. and you are typing, you are selecting female for gender, it should raise a flag for you to know that. So consistency check is responsible to ensure that there's some kind of logical alignment across all fields. Then we have range check. So range check just make sure that you do not enter values that are beyond the needed limits. So for example, when entering exam scores, exams are mostly mark over 100, okay, 100 over 100, and that is it. So if you have an exam score entering 120 over 100, then the range check should be able to raise a flag to say that no, what you are putting in is beyond the range, is beyond the value that needs to be there. It's beyond the maximum value it needs to accept. On the other hand, we have the format check. So format check needs to do with adhering to some specific format. So for example, emails should have the @ sign in it. You have postcode being written in a certain way, and then dates can also be written in different ways. Phone numbers also have a pattern in which they can be written. So this just makes sure that data that are entered into fields follow those requirements. On the other hand, we have check digits. Okay, so check digits, on the other hand, it's just a kind of validation that is done to make sure that data that is entered into a field is exact data that needs to be there. So they are used basically in barcode. Okay, so here in the ISB numbers, there's some kind of algorithm that takes place that when you add the digits and they don't add up, you go back to check for the necessary error in that. Now we move on to verification. So we have validation and then we have verification. So verification simply means that you want to look at visually checking to ensure that whatever you have on the form is what you're entering into a system. So that has to do with visual check. The one way we can do visual check again has to do with entering of password. So you notice that you have some double verification or double entry. So you are given opportunity to enter the same kind of data that you entered into the next field. For example, if you're entering in a password, to make sure that the two passwords you have typed in match. Okay, if they do not match, then it needs to trigger an error for you to correct it. If not, we all will be entering in passwords and then we will not be able to use the system again. All right, so that has to do with verification. Now, there's also the need for input formats. So basically, when you are designing a system, we've looked at the need for a file structure, how data needs to behave within the system, the data types. We've looked at that, and then we've also looked at the validation and then validation routine and verification. Next here is the input format, how data needs to be captured, right? So if you are going to capture data into a system, you can decide to do it either online. So you design a form. Okay, so just like we see right here, we have a form for JSC car rentals forms. All right, so it has some specifications here. So here you share the details or the link with whoever needs to fill this form, and when they are done, they hit on submit. Right, so this is an online version, and then you can also have a paper-based data capture form, and this here will also help to take the necessary data that is needed and stored onto the database that is required. Now we have an output format. So the output format simply tell us about the screen layout. So when we talk about the screen layout, it's just talking about how items are arranged. So the icons, the images, the names, how things are arranged on the system is referred to as the screen layout, right? And then the reports layout basically also shows how the report is supposed. Now, after you have designed a system, all right, so we're going back to the first stage. We've noticed an issue, we have to analyze it, and then you need to design a system. So in designing the system, you need to put down, how things are supposed to look like in the system. Then after you've done all those necessary design, then you go ahead and develop it. So you develop the system and then you test it, right? So during the development stage, you need to consider these key things as well. So you need to look at the database structure, okay? And then you look at the validation routines that we've mentioned already. And then you look at the input methods. What are the forms or ways you want to capture data into the system? And then how do you want to test them? And then finally, you want to consider or look at how this information or things you've captured into the system will be displayed. All right. So basically, if you look at it again, you notice that this whole thing is kind of like cyclical or repetitive in a way. All right. So you develop and you test. And okay, so under development and test, we have these three data types that we want to look at. First of all, normal data. So normal data simply is the numbers that fall within the range that you are looking at. So for example, for an exam score, people can get scores between 1 and 99. It's normal to get any score between 1 and 99. Okay, anyone who scores 0 or 100 is extreme. It's not easy to score a 0. So if you score a 0, that's an extreme case. We have to look at it again. And then if you score 100%, it means you are also exceptional. So those are extreme data, right? Then the abnormal data is any data that is not supposed to be within this range. So for example, -1, -0. So it's not possible to score a negative value when you are writing an exam. Okay, and you are not also supposed to write the exam score in words. Okay, so when numbers are entered alphabetically instead of in the implementation stage, right? So there are 4 main stages in the system life cycle. So the first one is the direct changeover. Then we have the parallel running, pilot implementation, and then the phase implementation. So under direct changeover, let's take this scenario. It's always best to remember it this way. Then you can easily remember the advantages and disadvantages. So let's take that you have a small business or a small firm that uses Mac computers or software, to design their project. Now all of a sudden they decide to use a software that can only work on Windows. Then in this case, there's a need to switch from Mac to Windows, and the user interfaces are not the same. So obviously there's going to be some form of challenge when you are doing the movement from one platform to the other. So when we talk about direct changeover, it simply means you stop using the old system and you start using a new one on a specific. Now, some advantages to the direct changeover is that it's immediate, and it's fast. Okay, whatever you intend to derive from this is very fast. And then you only need, one set of workers to learn this, right? And then on the other hand, the disadvantage is that there's a high risk of failure. So if the software fails, then it means that whatever you intend to do will come to a halt, right? Then if there's no data backup, then it means that whatever you have on the old system will be lost. Then there's a need to train people to use the new interface. So for example, in the case that we had here, if you are used to working on a Mac machine and we give you Windows, you struggle to use it a bit. On the other hand, if you're using Windows and we give you Mac, you notice that you struggle to use it a bit. So there need to be some training in using the two systems. So that is just a good picture for direct changeover. The next one is the parallel running. So with the parallel running, we can look at it also with this scenario. So we have a large retail store that deals in chain implementation, and they want to introduce a new POS, right? So if we look at this here, this is a new POS that they want to run, okay? And then they already have an old system where they just probably type whatever they need directly onto a computer, but they want to use a new system. So in trying to use the parallel method, what happens is that the two systems will be used hand in hand. Okay, so the old and the new system run side by side for a time before the new system takes over. So if the new system is being used and there's any issue with data entry, I mean, there wouldn't be much of a challenge because the same data has been captured on the old system since you are working side by side. So the disadvantage to this is that it's more expensive than the direct changeover because you need extra staff to, run both systems. You get it? Because, for example, you need to enter data, the same data on two different systems, all right? Then the advantage to this is that there's a lower risk of failure. So there's virtually no failure in this case because you are keying in data on both systems. The other advantage here is that it allows gradual staff training. So if staff are new to the use of the POS, with a gradual training, they get used to it and then they move over to using it. Now, it's more time consuming, okay, than the direct changeover. With the direct changeover, you throw away the old, you bring in the new, and you start working. All right, so these are some advantages and disadvantages to the parallel running. Then we have the phase implementation. Imagine a library is replacing its old catalog system, online catalog system, with a new one. So if we compare this catalog here, there's an old one and we are replacing it with a new one. So what the phase implementation does is that instead of taking over the entire system, right, it just take a section of the catalog and replace it or install it onto the new system and then check whether it works well. Then if it works well, then it moves on to the next stage till the system is complete. So here it takes only part of the new system is introduced, and when it proves to works well, then the new part is introduced, and it goes on and on until the old system is phased out. So again, there's a low risk here of failure. The disadvantage here is that it's more expensive than the direct changeover because you need to evaluate at each stage whether things are moving well and whether it is behaving in the exact way you want it to behave. So, for example, if you do the upload on the of the online books, okay, if you upload some books and then they are not exactly what you intend to see, then you have to do the necessary adjustment on that stage before you move on to the next stage. Okay, so it ensures some advantages here is that it ensures the system works properly before they expand. So they make sure that the system is working well before they move on. All right. So and as a result of that, it's going to take a longer time. So it's time consuming, right? It takes a longer time to do that. And so for another advantage is that there's an early feedback. If the system is not going to work, you get an early feedback to know that no, the software is not working well. Let's throw it away or let's do something else. Then we come to the last phase or implementation, which is a pilot implementation. Now, with a pilot implementation also, let's consider this scenario. where a company wants to implement a new employee onboarding software. So here, instead of having the entire company install a new software and use, they will allow only the marketing team to install the software and try it. So if they install the software and they try it and it works well, then they gradually will move on to the next department, and gradually the entire department or company will use the new software. So in this case here, a new system is first implemented in a single branch or department or office of a company, and its performance needs to be evaluated before it's rolled out to the other parts of the company. Some advantages is that if the new system fails, only one part of the company is affected. Okay? And then the disadvantage is that it takes just a longer time to implement the system across the whole organization. Now, another advantage is that it is possible to train staff in one area only. And then, because if we are dealing with the marketing department, for example, it's just the marketing people that needs to be trained for that period of time. Okay? And they will get to use it and train other people. And then the disadvantage is that it is sometimes hard to have one system working differently from others. Okay? So so the one disadvantage here is that it is sometimes hard to have one system working differently from the other systems. So I think at this point we can take a pause and then take a short quiz and see if we can answer any question based on what we have seen so far. All right. So the first one says that a developer is writing a program to record the result of examination taken by students in a school. The program will be tested to make sure that it works. There are three types of test data that can be used to test a system: normal, abnormal, and extreme. The question is asking us to explain what normal data is, abnormal, and extreme. I think you can pause this video. Look in the description button. You have the link to this video. Attempt solving it and see whether you get it right. Okay? And let's look at some other question. Name any appropriate validation routine for each statement. Each answer must be different. So let's look at this here. This has to do with validation routines. Let's see whether we get them right. So the validation routine ensures a password is always 8 characters. So we mentioned different types of validation routines. So this will be what? What do you think? Yeah, so this should be length check. So if you got it right, that's it. The next one said the last digit in a code used to ensure the other digits have been entered correctly. So this here has to do with check digits. The next one is this validation routine ensures that data has been entered into a field. So this is presence check. And then finally, this validation routine ensures that a date is entered in a format. So that's a format check. All right. So make time and then look at the remaining questions to see if you are able to attempt them. So on that note, let's look at the next part of the system lifecycle. So we have documentation. So now once a system is developed, there's a need to have documents on it. So basically two types of documents that we have here are the user document and the technical document. So user document, simply will detail out some of the things that you need to know about the system. I mean, the limitations of the system, the purpose of the system. If there are software specifications, it will state them out for you. And then some tutorials on how to use the software, basically. And then there's also the technical documentation that is used by the technical team, if they want to look further into the system, or they want to solve some problems within the system. So it helps to do some test plan. It also helps them to understand, some validations routines, okay, and user interface design, the flow chart, and then the system flow charts and system flow diagrams all comes under the technical document. And then finally, the evaluation stage. So at the evaluation stage, you just have to look at the new system to see if it is working exactly the way you want it to be. You compare it with the original requirements that you made, if it's a new system, or even if it's an old system. What requirements did you make? What were you looking out to get at the end of the development? Has it met those specifications? If yes, then you need to move on to, if it is no, then there's a need to do some evaluation again, and then if there's a need to do some adjustment, you do them again. So we evaluate systems and then find out if the hardware and the software part of the system are working exactly the way we want them to work. If they are not working exactly the way we want to work, then we'll go back again to the first stage, which is the analysis stage. So basically, that is it for system lifecycle. Quite a lengthy topic, but it's worth to look at it in detail. So that brings us to the end of chapter 7 on system lifecycle. I hope you were able to grasp all the details that is required for this chapter. So till we meet again, bye-bye.